Hello, my name's Mark Taylor. I'm from the University of Illinois in Urbana-Champaign, and I welcome the opportunity to present at the IFOR North American Conference with a particular focus on social sustainability and sustainable living. This is actually a kind of a follow-on from a presentation in a similar series that I actually gave in Brighton in June this year. So this is really the part two, looking at how we market a net positive future, with a particular emphasis on the supply side. The earlier presentation that I gave was focusing more on the demand side. And even in this lecture, I'm going to give a little bit of background towards looking at the demand side of a net positive future, because if we're looking at sustainability, we have to look at reducing demand. So I'll just introduce that first. So this is the abstract. Looking at two sides of this, really looking at energy supply and demand on a sort of technical sense in terms of energy demand, but also looking at it from the demands of clients and also the demands of building code. And because I presented this paper both in Europe and in America, I've looked at sort of different scenarios in both situations. And the background for the research is a house that we built here at the University of Illinois to compete in the US Department of Energy's solar decathlon competition. A house that did very well in the competition. Also, since it's been back on the campus here at Illinois, we've been monitoring it for its performance. It's a simple house, suitable for one person, maybe a couple. It's about 600 square feet, designed as one module to be taken to DC and back. The house was the first in the competition to actually use passive house certification as a way of modelling the performance of the building. So we worked with the passive house planning package, and that helped us design the building and analyse it before it was even constructed. The house did best in the competition against its students competing when the weather was against everybody else and against us. When it was cold and rainy and there wasn't much sun, our thermal envelope performed very well, and that's one of the sort of backbones to energy efficiency, is having a good thermal envelope. So on the demand side, so the architects have demands that they need to comply with, the demands of the building code. I'm a little bit more interested in this presentation in terms of the lay public that want to build green or live in a green home, but haven't got the background knowledge of the building code. And so there are some other helpers out there, things that people can look to decide what kind of house they want to have. So in Europe, there's a mandate to have certificates, energy certificates, which give you a rating. In America, we have the the HERS rating, and so average houses come in at about 100 points. That's a new construction to code right now. If you're looking at an older house, the performance is not so great, the numbers higher. Towards a net zero house, you're looking at getting a house that's down to 40 on the HERS rating, and then what pushes it to the zero rating is your solar panels and your renewable resource or your power demand. And then the other thing that I'd like us to look at is the passive house standard, which is simple in its definition, but maybe a little bit complicated to understand. So we have to get a little bit in depth there before we go further forward. So the passive house really is all about these numbers here. This number is 120 kilowatt hours per meter squared per year. So that is something about energy usage related to the square footage of your building over a period of a year. You can either have that in metric or imperial measurements. And then the other side of it is looking at the air-tightness controls. Now this is quite a bit beyond what building code is. Current building code for 2012 is 3 air changes now. And what we're looking at here for a super insulated passive house is something that's 0.6. So building into that, it's a simple, kind of straightforward, succinct standard, but maybe a little not too intuitive to an end user. And later on I'll sort of expound on that. I think that the information about having a well-insulated building has got out there. Maybe the general public and builders are less familiar or less comfortable with looking at the air-tightness controls. So this is the evolution of the air-tightness controls under construction. 2009, 7 air changes. This is uncontrolled air changes. This is air leaking out of the building. And if you can reduce that, you can reduce your energy consumption, and the bottom line is that you can save costs. This is your yearly expenditure for energy use. When the code gets tighter, 2012, this goes down to 3 air changes, and you're almost halving the cost of you're paying for power usage in the house, almost cuts in half. You go further still, go to the passive house standard of 0.6, and you're just down to $35. And then the passive house planning package, this is what we use to model performance of the gable home. It's a European, it originated out of Germany. There's now an institute in the US, actually based in Champaign, Urbana, and we looked at that program to help us model what we were doing. So it's in metric measurements, but we've done the imperial conversions here for the American market. So we've basically got a 12-inch wall with an R value of R50. So that's our super insulated wall. The construction of which was essentially 8 inches of spray foam insulation, and then on the outside of that, to stop any thermal bridging through the structure, we had an additional 2.5 inches of insulation, rigid insulation. And then beyond that, we just had essentially, this is decorative weather-resistant construction, some air tightness in that final area. So that's a little bit about the construction. What I'm going to move on to now is how the building was performed. And when we talked about the passive house standard, we were talking about how it's about a measure over a year's period. So what we have here is the 2 graphs, one showing the performance of the gable home over a year period, and then at the bottom we've got what our energy usage was over that same period. And Illinois is located really well to be able to do these analysis of a building performance because we have such a swing in temperature throughout the year. And we also have daily swings, which are also pretty high. So what you're seeing here in the thin blue line, which goes up to be a kind of red line, this is our exterior temperature swings during the day and over a week period, going down to maybe 9 degrees here, and then up into the 90s up here. And then what we're trying to do is we're trying to maintain a unified or comfortable interior condition somewhere between 68 and maybe 78, 68 in the winter and maybe 78 in the summer. We had some issues trying to be able to achieve that in 2013. Since then we've recommissioned and we're hoping that this year the results are a little bit better. And then down here you're seeing our overall energy usage, which you can see is very closely matched to the green line, which is our HVAC system, our conditioning energy recovery ventilator, which basically conditions the space. So that's really our main draw. And here I've just superimposed what our energy usage is on top of this graph. And you can see that in the spring, when the climate isn't too demanding, our usage drops, and then here when we're in the winter, we're really trying working hard to actually with some additional heating to bring that temperature up, and then in the summer trying to use it to bring it down. So on here you can see basically the peak heating load, peak cooling load, and I'm going to go in a little bit more detail at these critical times of the year when the demand on the house is at its worst. And the other thing that we've got on here in terms of the light green line, that is our the sort of the positive side of the story. That is what we're able to generate from solar panels on the roof. So you can see these are at the same scale, so we're being able to produce a lot more than we're actually consuming. And those are reflected in these numbers as well. So this is how we do it. This is a close-up on a week. And so this is a week at the end of January this year. And what you're seeing is, this is how the solar panels is making power for us. And then here you've got the combination of the CERT unit, which is doing the bulk of our air conditioning. And then at the times when it gets particularly cold, we have two of these fan heaters which will cut in and we'll get a sort of an additional spike on energy usage. In the summer, it's kind of interesting what this software allows us to do is we can actually get an understanding of what the climate's doing as well. So what we're seeing here, where we've got a sort of more irregular pattern, one can assume that during that day it was more cloudy. And then the knock-on effect will be that because it was a cloudier day, the house didn't get so hot, and so our air conditioning unit, this is in the summer, wasn't running so much. And then as we get into the next day and the sun comes out and it's a pretty hot day, then our air conditioning needs to kick in again to help us get down to those desired temperatures. You can see over here we probably had a period of quite a lot of hot days in the summer.